All right, in this module, we want to talk about division of fractions, rational expressions. Before we even look at the PowerPoint, let's just talk. I'm a teacher. Let's say in my class I have 20 students, and I want to do some group work. So I want to take my 20 students and break them up into groups. Well, I want to take my 20 students and break them up into groups of 2. That would be division, and it would give me 10. I want to take my 20 students and break them in groups of 4. That would be division. I would get 5 per group. Say I had my 20 students, and I wanted to break them up into 20 groups. That would be 20 divided by 20, which is 1. So your basic premise of division is the concept of taking a total, an amount, and breaking it up into equal number of groups, which means your divisor has to be a whole number. Think about this. If I had 20 students and I said, hey guys, we're going to do a project. Everybody divide into a half a group. They would look at me kind of funny, because that doesn't make sense in the real world. How can you divide into half a group? You can't. So the basic rule is to do division, your denominator, your divisor, has to be a whole amount. It can't be a fraction. So what happens in fraction land that we're in, with rational expressions, you really can't do division. You cannot perform the operation of division with fractions. I'm saying it. I'm telling you it. You cannot perform the operation of division with fractions. Instead, you're going to learn to rewrite the expression. And the operation that is the inverse of division is multiplication. So when you see 2 fractions connected by division, it can't be performed. What you have to do is rewrite that expression as its inverse, which is multiplication. We never divide fractions. We rewrite the statement as multiplication. Now, when you rewrite it as multiplication, you have to do something. And what you have to do is you have to take that second fraction, the one that's behind the division bar, and you've got to take that second fraction and, in slang, flip it. Flip. The correct word for flip from elementary school was the reciprocal. The correct algebra word for that is your multiplicative inverse. So, I have a little song. Dividing fractions easy as pie, flip the second and multiply. That song tells you if you see dividing of fractions, the first thing you do is take the second fraction and flip it. The correct word for flip is reciprocal. The correct word for reciprocal is multiplicative inverse. All that's saying is whatever fraction you have, you're going to take the denominator, put it in the numerator, take the numerator, put it in the denominator. That's what flip means. And once you flip that second fraction, the division now becomes the operation of multiplication. And we're back to where we started. I want to make sure you understand what the reciprocal means. If I have a fraction, negative 2/3, and I ask you to do the reciprocal of it, I'm not saying make it the additive inverse. I'm not saying make the negative go away. The multiplicative inverse or reciprocal means just to switch your locations. So if you have a fraction, negative 2/3, the negatives stay in there. The 2 goes to the denominator, the 3 goes up to the numerator, and now your reciprocal is negative 3/2. Okay? So don't get that confused. All right, let's look at our example. 36 over 50 divided by 48 over 75. I want to do division of fractions. It doesn't exist. We rewrite the statement as multiplication. So the first fraction stays put, 36 over 50. We rewrite it as multiplication, and we take the second fraction and we do the reciprocal, the multiplicative inverse, which would be 75 over 48. Now it's your call. You can multiply going across 36 times 75, 50 times 48, but I really don't want to make those big numbers. So instead, what I'm going to do is I'm going to start doing my canceling, my reducing. So I'm going to start my first numerator, 36, and I know it can divide with 48 because they have a common factor of 12. So 36 divided by 12 is 3. 48 divided by 12 is 4. So now I have a fraction, 3 over 50 times 75 over 4. I notice that my next numerator, 75, can reduce with my denominator, 50. Their greatest common factor is 25. 50 cents, 75 cents are all quarters. So their greatest common factor is 25. So 75 divided by 25 is 3. 3 quarters and 75 cents. 50 divided by 25 is 2. So now I have 3 over 2 times 3 over 4. Watch, boo-boos. Do not go cancel out the 3's. Both 3's are now in the numerator. They're connected by multiplication. The only time you can cancel is doing division. And that means one number's in the numerator, one number's in the denominator. So now all we're left to do is multiply. 3 times 3 is 9. 2 times 4 is 8. My product is 9/8. I know that's an improper fraction, but in algebra, we leave improper fractions. Do not rewrite that as a mixed number. All right, let's go to the whiteboard.